Hey, happy Sunday. This is PFG Live, the podcast that asks you to get flat, stay flat, but not necessarily level. Welcome aboard. We got a good crew showing up in Discord and on YouTube. Let's see. We're getting a bunch of weather reports flying in here. Warren Jones in Sutton, New Hampshire says it's 61 Fahrenheit, overcast, 80% humidity, winds calm to 5 miles an hour. Remarks are snide. Dale, Widget Works in the Edmonton of Alberta says it's 14 degrees science and mostly cloudy in Canada. RJ's Workshop near Laramie, Wyoming says it's 59 degrees Fahrenheit, 35% relative humidity. Winds are east at 20, gusting 33 miles per hour. DBX near the White Plains, he's reporting winds are 170 at 6 knots, visibility 10 miles, light drizzle, broken at 1600, broken at 2100, overcast at 3300, temperature 20, dew point 16, altimeter 2993. Evils made up some crazy shit. Tucker is with us from 53 Fahrenheit and cloudy in the Buffalo, New York. Josh says the audio is check in southern Manitoba. He reports from Charlie X-Ray Mike Delta that the winds are 190 at 13, gusting 18, temperature 26. That's science, folks. Dew point 01, and the remarks have remarks. Too damn warm, he says. Bill Olney reports 61 and gloomy in Rome, New York, home of the Air Force Research Lab. Evil says it's about 22 science on the non-networked sensors. Excellent. Ted Hyde. Welcome, Ted, from Casa Frog Pro Resources. Let's see. He is the nearest active is London, Ontario. Charlie Yankee, X-ray uniform, where it is 070 at 19, gusting 27 knots, 15 miles visibility, broken at 3300. Temperature 12, dew point 05, altimeter 2992, and it's cold, says he. On the YouTube side, we have the first check-in was CJ Stevens, who reports 64 degrees and sunny but windy in East Tennessee. Welcome aboard, sir. The Redskin Garage is here. Welcome. You are watching the Carter Crew and you stopped for this. Dude, you are committed, or should be. CJ Stevens is working on the wood chipper. Nice. Langerman Design says it's 75 degrees, partly cloudy, light southerly breeze in eastern Rhode Island, where it is always delightful. Greenwood AG says it's 46 degrees Fahrenheit. Winds are 13 west-northwest in central southern Ohio. If you gave us one more adjective, we'd be able to walk in your front door and probably drink your beer. Welcome aboard, everybody. Right here in the Windham, New Hampshire, it's 66 degrees, 83% relative humidity, and the winds are out of the northeast at 4 miles an hour. And to back that up, we have Manchester Airport, which is on your screen, reporting winds are 060 at 4 knots, 1 3/4 mile visibility, light rain, mist, overcast 300, temperature 16, dew point 14, altimeter 2996, and that's all we care about. Welcome. I hope you guys had an awesome week. I think I did. I'm still here. I'm vertical mostly, so that's good. It was busy. Many projects. Some projects we'll talk about today that had me running up and down the stairs. So if you don't know, my lab, my electronics lab is upstairs. The shop is right under it. And the 3D printing is in the basement. So if I have a project, which I do, that involves all of those things, I get my steps in pretty early in the week. So we're going to try to have a new little structure here on the PFG Live. And one of the items is community notes. So I want to jump over to a community note, which I want to share. So if you have community notes, you can send them to me before the PFG Live, and we will announce them. This came from one of the guys that runs the Indiana Engine Show. That is a machinist group, and they have an event coming up. So if you're interested, head over to indianaengineshow.net. He says, we're a machinist group in Northeast Indiana. Have a favor to ask. We put on the Indiana Model Engine Show, hobby machinists showing off their creations. Lots of videos on the website. Would you consider sharing our event flyer on your social media? Just did, dude. Welcome aboard. Let's see. The second community note Oh, there you are. You're here. You're here, dude. You're in the chat. You're welcome. I hope that does it, Aaron. Everything is on that site, right? So you're all set. You even get to give me feedback. Evils has posted an ISO standard protest in the chat. I recognize your protest, sir, and it will be on the agenda for the next meeting. All right, awesome. The second community note is very simple. Next Sunday is Mother's Day, and if you know what's good for you, you will do something about that. So next Sunday will not be a PFG Live because of Mother's Day. I can't get it to work. I will be at 2 o'clock. I will still be down at Mom's. So no PFG Live next Sunday, which is, what's the date next Sunday? The 11th, May 11th. The next community note has to do with our Discord server. So we've been inviting people to the Discord server in like 3 different ways. And for reasons, we're going to narrow it down to one way. And it's pretty simple. If you want to join the Discord server, head on over to pfg.gg/Discord and follow the instructions that appear before you, and you will be able to join the Discord server. We're taking steps that is the only way to join the Discord server. We just made some changes this morning with the help of my in-house IT guy, who also gets to sleep and eat here. Let's see. And to give Evils his due, he says, my community note is, while Spencer uses the occasional date notation that looks similar, ISO 8601 is the only internationally standardized date format that is sortable. So I use year dash and then a 4-digit month date code, and I believe the standard is 2-digit month dash 2-digit date. Is that right, Evils? So except for the 1 dash, we're pretty similar. That's what I love about standards. There's so many to choose from. Yeah, it kind of is, Josh. Okay, there we go. Nice. I don't know, Evils. I have some internal systems that won't deal with that, but I acknowledge your international standard. So those are community notes. If you have any community notes for the next PFG Live, please send them along, and we'll be happy to announce them. Next, I want to give some shout outs. A lot of things happened in the last week or so. Of course, I want to say thank you again to Brandon, who was here from Inheritance Machining last week. Brandon, we had a great time. That was a great conversation. Everybody seems to agree. And Brandon, you now hold the record for the highest viewed guest segment on PFG Live. Congratulations. And for that, you will win absolutely nothing. Let's see, John Saunders. Thank you, John, for the hat and the swag. So I get a message from John the other day. He's working on Johnny 5, and he has an interesting Johnny 5 problem. And that is the subject of one of our main things today. So we'll talk about it in a minute. But I just wanted to say, give him a shout out and say thank you. I got a very nice message from Aaron Walla. Aaron is a member of our community. He has become a terrific tool maker and grinder hand and just does a great job. Aaron was the inspiration for the PFG stones known as the minis. He was the one that came to me and said, "Hey, we need something smaller for us guys," and that gave rise to the mini stones. So just wanted to say hi to Aaron. Let's see. A shout out to Dale at WidgetWorks. Dale has done a really nice thing for his community. He got his bamboo H2D printer and immediately put it to work printing Minecraft figures, 2 different kinds, skeletons and creepers. The picture on your screen. And he printed enough for at least one for every kid in the school. Dale, you're awesome. Nice job. Let's see. Another shout out. Just Tuck, Iron Man. Tuck got a new H2D, and we were just looking at his installation today. So congratulations on that. And my makerspace, the Make It Labs in Nashua, New Hampshire, also got the H2D up and running. So we've got a bunch of H2Ds running around, and I have to say, I'm pretty impressed. I may have to wear out one of my X1Cs first before I can consider that, but we'll see. We'll see what happens. You never know what's going to happen. Let's see. Redskin Garage, welcome aboard, sir. Where are all the atoms? So, yeah, interestingly, today, I think our atom count is pretty low. But who knows? You never know what happens as the day goes on. So, let's see. Anybody, did I miss anything? Any community notes or shout outs before we get on to the segments, the normal segments? We shall see. Okay, so while we're on the topic of 3D printing, I thought I'd share a little project that I had to do. Oh, we have one atom. Okay, so there's one atom in the chat right now. I have a goal, people. I have a goal of 5 atoms in the chat simultaneously. I think we can do this. So I will see if maybe for 2 weeks from now, which is the next PFG.Live, we can get 5 atoms. That's my goal. 5. So you can't achieve a goal until you state it. Collection started. I have a project going on, which I've shown bits and pieces of, but I can't talk about the whole thing because I don't have permission to. But you may have seen me post about this. This is a connector, a coaxial connector for high power RF, known as a DIN716. Yeah, Josh says that we have to have there's a rule that we have to have at least one atom to start the regular topics, and we have achieved that. So when you buy one of these connectors, which, by the way, anybody want to guess what one of these connectors cost? I don't think I can fool you guys. You probably know what one of these connectors costs. It's like the connector itself is like, any guesses? $57 before tax, negative, too low. Anybody else? Well, that is correct, Josh. More than what you want to spend. These are about $75 per connector or something. I can't quite remember. And then I go ahead and I design and machine an extension to it. Okay, because it's a little stubby thing on the back, so you could add that money. But it comes with a nice cap over the front of the connector. And when I finish the equipment that I'm building, 37% of the GDP of Luxembourg, might be 38. I'm not sure. So I want to ship it with the factory cap that it comes with. But the problem is that this is a painted piece of equipment. This is going to get very nicely painted, as a matter of fact. So I wanted to design a cap, and here it is, that I could 3D print and put on there, and then that cap would be disposable. So the unit would get painted, the connectors would be protected from the paint, and then at the end of the paint cure, these can come off and get tossed, and then the factory cap can go on for shipping. Now you can make the argument that why not do it the other way around? Well, one of the reasons is the factory cap doesn't go deep enough to cover enough of the connector for painting. But anyway, I thought I'd show you that. And on the screen is that, I did overnight. I made everything I needed for the project. So it came out pretty good. And that was, by the way, that was the Polysonic, Polymaker Polysonic PLA Pro in any color you want, as long as it's black. So that's a little bit from the 3D printing gallery. Let's see. So 3D printers have been running. We shipped all the PFG Stone orders. There's 2 waiting to go to the post office tomorrow. a bevels order came in, and the system is sufficiently smooth now that when a bevel order comes in, it's not a pain to knock it out. It's really straightforward, and that makes me very happy. So it gives me time to go have lunch while it's doing it. So today, let's see, where's our slide? We have a couple of interesting topics, and I like the fact that that the guys were asking me, what tool were you talking about? Okay, take care, Redskin Garage. Thanks for checking in, though. We'll see you later. So the topic was called "You'll never use this hand tool in the shop," and I show a picture on the slide, and everybody started guessing. Which tool are you talking about? Anybody want any more guesses? You could put it in the chat. What tool I'm going to talk about? Never use this hand tool in the shop. Anybody? Bueller? Well, I will tell you a story. No, I do not use calipers to tighten SMA connectors. They're evils. So I was working on something, and honestly, I cannot quite remember what it is, although I do remember the wrench. And it was one of my Snap-on look-alike wrenches. And I just remember I was a little bit bent over, tightening or loosening or something, and the thing just wasn't coming out, and I started hitting it to loosen it up. And do you know what that tool did? That tool bit me, and it caused a hand injury, which is right there. See that abnormality right there? That was from smacking a wrench with my hand. Now, I know what you're thinking. You're thinking, well, why were you so stupid? Yeah, Josh says, done that too, right? So I was a little bit triggered. I'm not going to name names or call out the particular video, but I was watching a video, and I saw somebody who I care about smack a wrench with their hand, and it looked mighty close to how I injured my hand. So Dale says you're supposed to use your head as a hammer, not your hand. That's correct. I should have hit the wrench with my head. It would have been better. Yeah, Josh says also with chuck wrenches and vice handles. Yes. And the vice handles, the thing with vice handles is they look like they're meant for your hand. Fine. But when you can't open them, what are you going to do? You're going to tend to smack them. And, this causes injury. And if you do it a lot, it's going to cause a real chronic injury that is not going to go away. Now, I'm fortunate that my injury ended up being cosmetic more than anything else. I'm sure some clever physical therapist, I'm looking at you, Rob, could measure it and tell me, oh yeah, you lost N% of whatever. But I was fortunate. But you only have two hands and you have lots of hammers. So I want to talk about this a little bit because I want you to not end up in the same place. Chuck wrenches, chuck wrenches are another major contributor because you're there at the chuck, it's too tight, and what are you going to do? You're going to tend to hit it. You're not going to tend to get some other tool. So here's one of the things I've been thinking about is that for each one of those stations, right? The lathe is a station, the VNC is a station. If you have a need for something where you might find yourself hitting it with a body part, I'm not judging. You should make a tool or have an existing tool that you can use to get the additional leverage or to get the additional thwackage to do what you have to do. It is it's not good to use your hands. Now, this is coming from, I'm a 4th degree black belt in Taekwondo. We're trained to use our hands. This is normal, but the way we use our hands in the shop against a blunt metal thing, not good. So we would like to avoid that. Okay. I brought a selection of weird tools with me that helped save my hands over time. Art that makes art. Welcome aboard, sir. He says the old guy who taught me had several wrist surgeries, ending up with them both being fused. Wow. Well, that's a good example of what not to do. Greenwood AG says, I've finally gotten older and wiser most of the time. I have soft blows all over the shop just for this reason. Yeah, he's talking about soft blows. This is my little weenie soft blow. Dan Gilbert, hey, welcome, sir. Nice to see you. From down south, the deep south, the deep south of MIT. So Evil says your hands are not licensed as a blunt impact tool. No, they are licensed in another category. So you're not supposed to use them that way. Here's a funky tool I made in the Brown and Sharp Micromaster grinder. There is a filter that is inside, underneath, up around, really hard to get to. And if you try to get this filter off with your hand, it is absolutely horrible. Carl says, God invented sledgehammers for a reason. Absolutely true. Robin says, a 1/2-inch Harbor Freight torque wrench for the lathe chuck with adapters. Not only is that a good idea for preventing injury to your hands, but now you have a torque wrench and you can be consistent. Who would have thought that would have come from Robin? Thank you, Robin. That's awesome. I actually have a little weenie torque wrench. I think it's a 1/4-inch drive. I can't remember, but it's really nice for doing that for little parts on the Kurt Weiss. Stephen Tessier says, what would that category be? Sir, that's classified. Josh says, keep your vices clean and lubricated. I think everything should be kept clean and lubricated. Anyway, this thing saved my bacon. This is a weird wrench that I made. It slid over the hose going up to this filter, went over some nut, and then these holes, I have a spanner tool that picks up these holes and allowed me to get this thing loose. Had I tried to do that in any other way, I guarantee injury would have occurred. So there's one example. And if you're not watching the video and you're listening to the audio, this is a 3D printed tool. I don't remember a lot of the details. This actually might be PETG, but it's very solid. I don't remember the infill, and it won. It did the job. So there's one example. My most used thwacker is at the grinder, and this is a little brass thwacker. It has it's mostly about about an inch diameter, and then it's about 1.5 inches diameter at the bottom end, and it sits on the grinder. And as you can see, it has been hitting things a lot for quite a while. And this particular thwacker is used instead of me picking up some random object or trying to hit things with my hand to move them around on the chuck. Now, admittedly, you have to have a metal thwacker on the vice chuck if you're moving things around while the magnet's on, just because you need that little tap, tap, tap. But trying to do it with your hands would be a very bad idea. Somebody brought up the soft blows. So I have a whole series. This one is a Compo Cast Dead Blow Unicast, made in USA, Stanley. These go up from, this must be quarter pound, 5 ounce. So this is the littlest one, and they go all the way up to big. and these are nice for smacking things. And in the story that I was telling about, hitting the wrench, one of the bigger ones of these would have been perfect, and they won't slip much. They're soft. It would have done the job, and again, would have saved the old hand. The tiny ball peen hammer is a good idea as long as what you're hitting isn't going to be scratched or dented. Hey, Bart Harkema Metalworks. Hi, Bart. Welcome aboard, sir. He says he's a bit late, but it's 9 degrees science in the Netherlands. Welcome, sir. Nice to see you. One of these is good to have handy and might do the job. Here's 2 other little special ones. This is one that I made a million years ago. This is a brass. It's just a small brass double-headed hammer, and obviously it was made from a very special piece of brass. And you all are probably familiar with it. It's the one that was handy, and then a wooden handle, which I think I bought at the hardware store, and that is a favorite thwacker also for not using the hands. And finally, this one is super cool because I have no idea its exact history, but this was found in my grandfather's toolbox, and it's a rawhide mallet, which I know is a thing. And it has a repair to the handle, of course, and it was used for thwacking some lighter things. So who knows? We'll see. Another important tool is just leverage. If you're trying to work on a wrench and it's not moving, and you're very tempted to hit it with your hand, if there is a tool to increase the length of the wrench handle, which could be as stupid as a piece of pipe, you could switch over to that and not hit anything with your hand. So you guys could chime in with any other things that are in the same category. Sometimes, chisels, you would tend to want to hit a chisel with your hand if you're doing some little wood thing. Also, just use a small hammer and avoid wearing out the body parts. One of the things that I have experienced in recent couple of years is the onset of some arthritis in my thumb joint, which is completely hereditary. I could trace it back a while. And it's another thing where you don't, it doesn't feel good to grasp things or hit things just the wrong way, and that joint can be really, really hurt. So there you go. So for each one of your stations where you have that problem that may arise, I urge you to come up with a solution that does not involve smacking it with your hand or your head. Warren Jones says, 20-pound sledge, either it goes or it's stuck. Or, of course, Warren, you have the liquid wrench. enough therms and it turns into liquid, and then it's no longer a problem. So really, I can't come up with a situation where it's not. Josh says it can't be stuck if it's liquid. It's usually your hands that are at the biggest risk here, and hitting things with your hands. We could have a little class on hitting things with your elbow if you want, but that would be a different session. Do any of you guys have special tools to add leverage? Like I can imagine a 2x4 with a couple of studs in it for getting around a very stubborn vise chuck wrench. Does anybody do that kind of thing? So that is, never use this hand tool in the shop. Now you get it. Oh, is that called a snipe? Dale says a piece of pipe, and he called it a snipe. Is that a new word for us, Dale? I've never heard that. And Josh is agreeing, a piece of pipe. And Bart says, I did some blacksmithing with a 12 kilogram, 26-pound hammer, anvil on a stick, but you feel that in your hands the next day. Yeah, it amazes me watching the guys that do forging. I don't want to be that elbow. So I would imagine that I don't forge.
I am not an expert.
I don't forge, so I don't know how this goes, but the air operated hammers seem like they're a little better than hitting it with your arm. Redskin Garage says he has nesting breaker bar pipes to extend the bar about 1 mile long. What is that in kilometers? Is that like 1.7 kilometers? Art That Makes Art says, I just made a wrench for the chuck nut on the clausing lathe. Awesome. Robin says, hardened steel block to use on finished parts with the brass thunker. Nice. So you put the hardened block in front of the part and then hit the combo with the thunker? Is that your... Let's see. Evil says, I've used a PTFE hunk to tap down a stack of hardboard strips before sawing a slot into them. Also, wood stick as a very light hammer. That's a really good idea. I suppose you could use the handle. Yeah, so just a piece of wood as a thwacker is not a bad idea if you're not opposed to that sort of thing. Okay, thanks for the clarification, Robin. So Robin's putting a hardened block up against the part so he doesn't mar the part, and then hitting it with the thwacker through the block. Evil says the back of a screwdriver. You know, I don't have one handy, but yeah, using the back of a screwdriver. Now, people would, bristle that you're going to use a screwdriver handle as a hammer, but of course we know we're using it as a thwacker, and that's what makes it okay. So Daniel Gilbert says, I made a nice slide hammer with a custom end so I can continue to make special things for it. Special things. Chop Smitty says, in astronomy, if it's requiring a thunk, I'm doing something wrong. I don't deny you your lack of thunks, sir. Dale says, putting a piece of pipe over a hex key is great. When the fastener snaps loose, it could be very hard on your hand. So I think what you're saying, Dale, is not even necessarily using the piece of pipe as an extension, just using it to make the hex key a little safer to grab, which is pretty neat. Let's see. DBX says, hang on, I don't want to miss this. Plain adjusting hammers, elegant versions of what's been discussed. Look at those gorgeous hammers. That is beautiful. So one of them is a brass hammer and one of them is a steel hammer with a brass end. Very cool shapes. Very nice. And Dale says that, yes, we got it right. So a small piece of pipe over a hex wrench to keep your hand happy. Chris O says, for light work, I use Delrin or G10 as a thwack extension. I like it. I like Delrin for lots of stuff like that in the shop. Robin says, Delrin rod to tap a measuring setup to shake out most of the hysteresis. Yes, yes, yes. I have a little piece of polycarbonate rod, I think. Of course, which is probably 6 inches long by a 1/2 inch, and I use it as a little tapper. DBX clarifies and says that those very nice hammers he was showing, wooden on one end, wooden end on the brass one, leather on the other. Nice. Excellent ideas. So all in all, outstanding thoughts, and I encourage you guys to think, if you've ever injured yourself doing the hammer hand, we have a move in Taekwondo called the hammer fist. You could think of, what could I have in the inventory to do that instead? Make it, put it in, and start using it, and teach others. because I don't want anybody to get injured. So another category, and again, it's still the hand, it's just not impact. Another category is TIG welding. Oh, look at this one. Warren Jones is showing something amazing. It is a hammer. Wow, you guys are sending these in fast and furious. Warren, that looks like a soft blow hammer, but what are the faces made out of? It looks like brass. Is that brass? That is pretty cool. Josh says, if I teach my coworker, who is going to do it for me? Look in the mirror, buddy. Michael Juan shows a gorgeous little composite hammer with a brass face that looks like it's replaceable. Very nice. Oh, so Warren's big hammer, the hammer of Warren, this is now the hammer of Warren, you know, is leather. That's, I guess, end grain rolled up leather in a big, heavy hammer. Oh, look at that. Michael Wan is giving us a much better view of this little thwacker. That's beautiful. What a nice design. Is that commercially made? And if you're listening to the podcast, I apologize. There's a lot of graphics going on here. It's a steel head, but it has a very clever dovetail for a slide-on piece of brass, and it's beautiful. Very nice. Let's see. Here's Dale's picture of the hex key snipe. Just a chunk of heavy wall pipe wrapped around with hockey tape. See? In the land of hockey, they know how to protect their hands. Very cool. These are all great ideas. So we've been talking about your hands errantly being used as a hammer. Now let's talk about your hands during TIG welding. So I TIG weld, I admit it, and I like the very thin, sometimes they're deerskin gloves for TIG welding, so you can be very delicate about things. And sometimes things get hot, so you want the gloves. That's protecting your hand. But there's something going on that is not terribly obvious at the time. I used my cough switch. And that is ultraviolet radiation. Ah, Dale got it. When you are working on a TIG weld, and you're using both hands, one with the feeder, one with the torch, your hands are the closest thing to that arc, and the ultraviolet radiation is intense, and there's a lot of it. Now, you have correctly put on your helmet, and you have your UV protection for your face and your head and your eyes. But if you are welding, if you are TIG welding gloveless, you are exposing your hands to some pretty high UV radiation. And that, I don't want to use the C word, but that could lead to skin cancer. You have to be a little careful with that. And yeah, I know it's yet another thing to put on to go do your TIG weld, and you want to do it real quick, and you don't want. Please just do it. I don't want you to get hurt. And those fingies are the closest thing to the radiator. In antennas, we say that it's a point source, and it's an isotropic radiator, and you are the closest thing, and it goes as R squared. So if your face is 4 times further away from your fingers, that's 16 times less radiation. Yeah. So that's, yeah, Chop Smitty says aluminum is the worst. A lot of power. So aluminum, there's a couple of things going on with aluminum. There's no smoke, right? There's no nothing. The air is clear, the power is high, and the arc is very bright. Please wear gloves and save the hands. Carl says Joe Collier's TIG fingers? Question mark. Jody. I don't know if I pronounced that well. Jody Collier's TIG fingers. Jody, of course, is the Weldmonger, and I have his TIG fingers, and they're wonderful, but that does not replace gloves because you need the gloves. Let's see. Evil shows a picture of his brand new gloves that he just got. Maybe some old ones on the bottom of the pile. Greenwood AG says guilty, especially for something quick. Funny, but I could smell the burnt skin in the shower at night when I cheat. Yes, sir. So could we please ask you, as a friend of ours, to start wearing your damn gloves? Thank you. Yeah, CJ is saying gloves are for the light protection. So I like the really thin ones. And yes, they wear out a little early. Yes, if you wear a TIG finger, you won't wear them out from sliding around. But buy them, wear them out, and buy new ones. Yes. Everybody's nodding their heads up and down. Yep. CJ Stevens says, deerskin, nice and slippery. So that's the other thing that concerned me in watching videos is sometimes I'll see somebody TIG welding without gloves on. Please don't. And this is why. It's the radiation, the UV radiation. I could see spot welding and specialty welding setups where there's a shield over the electrode where you put it down and you hit the button and it does its thing, but the shield is going to take care of you. But if there's no shield, you have to put some brain cells on it. Also, yeah, CJ Stevens also says there's no excuse not to wear thin sleeves. So that doesn't excuse your arms either. I have this green, it came from Airgas. I don't know what company made it, but a green shirt, fire resistant fabric, and it's long sleeves. And then I put the gloves on and I put the helmet on, and I'm good to go. So good. I'm glad we talked about that, because that was something that was bugging me. Was the taking care of your hands. It's the only thing, if we lose these things, we don't get to play in the shop anymore, or we don't get to make money anymore in the shop. And that's not good. And these things are complicated. These hands have a lot of joints, and they're the closest thing to the site of the work. Cool. Well, you guys are great. Lots of good contributions, and I appreciate it. Let's see. Evil says, can't have enough TIG gloves. He showed his picture. €4 for the worst pair there. €8 for the best or second best pair. They're not really, they're not super expensive. And I'm down at Airgas so much. In fact, I bet you're one of my Airgas buddies. You're watching this. There's no excuse. All right, let's move on. We have to talk about your lathe is killing your Wi-Fi. So this is a topic that has come up a couple of times. A few months back, Tucker pinged me, and he was having real trouble getting his Wi-Fi in the shop. So we analyzed the situation, and it turned out that his shop was, a garage, mostly a metal building. His Wi-Fi router was in the house. And what do you do? So we came up with a plan, and we figured out how to get him up and running with the addition of a repeater, repositioning the router that was in the house. And in the end, he got his Wi-Fi problem solved. But I'm not just talking about Wi-Fi. So that was sort of a shortcut to talk about radio communications. And I'm not just talking about your lathe, because that was also just a shortcut to talk about electrical noise. I get this message. It comes in from Mr. John Saunders, who would be with us today, except he's doing something much better. Just kidding. So John pings me, and he's like, "Can we talk?" I'm like, "Yeah." So he has this setup where he's rebuilding Johnny 5. Let's get serious here. He's rebuilding Johnny 5. and his project is going along fantastically. He wired up the motors, for the motion, and he noticed that when he used his remote control to initiate the motors, the motor motion, that once the motor motion initiated and he pulled back on the controls, it wouldn't stop. And we sort of brainstormed a little bit about what's going on, and I said, I think you have a noise problem. So my model of what was going on was that he had the wires from the controller running and the motors running into the chassis, up around. There was a big wiring harness, and when he turned on the motors, these are stepper motors. Even if they're servo motors, it doesn't matter. But today, a lot of controllers are pulsile in nature. They generate pulses of different widths and different frequencies, and that's what controls your motor to generate torque and ultimately motion. So the problem is that when you generate pulses of current, a pulse with sharp edges on it has a very broadband signal. Okay, and the wires being very long and stringing along through the box acts like, I know, here comes the word, an antenna. And you can generate a lot of junk radiation over very wide bands of frequencies because of these pulses. So the theory is that when John turned on the motors for motion, they started moving and generating electrical noise, which was coupling back to the receiver of the remote control and deafening the receiver. So now the receiver can't hear you give the command to turn off, and it just keeps going. So that was the theory. John tried something in which he disconnected from the long wiring harness, wired it directly over a shorter path, and guess what? It worked great. So I thought about it, and I ended up sending John a bunch of what we call ferrite chokes. So I'm holding one up on the screen right now. This is a ferrite bead, which is split in half and put into a plastic housing, which can be closed to close up that bead again, and you can snap it around a wire. Okay, here's one that's closed up. All right. And you can see there's a hole through it. These are meant for approximately 1/4-inch cables, 6-millimeter cables. And that puts a ferrite bead around the wire. Michael Juan says, our lab built an RF sputtering chamber. Ended up making a lot of people angry. So an RF sputtering chamber generates a lot of RF, which, unless you're the guy doing the sputtering, we call junk or radio frequency interference. And this is what we're talking about. So a piece of ferrite is a form of iron oxide, a certain crystalline form with some herbs and spices. And it has two very important characteristics. One characteristic is that it has a very high magnetic permeability. That means magnetic field lines want to travel through the material. The higher the permeability, the more the magnetic field lines would rather travel through that material than through the air. Air has a relative permeability, by definition, of 1. So the material in this split ferrite bead might have a magnetic permeability of 100. Okay. So as a wire that might be carrying some really crufty RF noise goes through the bead, the current is going to want to induce its magnetic field in that bead. So two things happen. Number one, the inductance of the wire goes up, okay, by a bunch, and therefore the higher frequencies don't want to keep traveling because it looks like an inductor. The second thing that happens is this material is depending, and it's all material dependent, designed to have a loss so that when that high frequency radio frequency energy gets into that bead, it turns into heat and literally is dissipated. So we call these things RF chokes, or chokes for RF energy, and we snap them on wires. This should not be a big shocker to you, because years ago, when the FCC requirements got stiffer, companies had to start putting ferrite beads on the wires coming out of some of their stuff just to meet FCC requirements. And so a lot of the things that you've probably purchased in the last few years have this lump on one of the power lines. That's what's in the lump. So what I did is I suggested to John that he put one of these on each of the battery leads close to where they go into the motor controller. One of these on each of the motor leads close to where it goes into the controller. One of these on each of the motor leads where it goes into the motor. And then, for extra credit, any other wire, including the coaxial cables to the antennas for the remote control, can get these snapped on them. The switching elements, the things that turn on and off and are switching the current to the motors, is inside the motor controller box. So it's the noisemaker, okay? The motor might also be the noisemaker. So this is the order of operations. And we're awaiting, the results of the experiments. So in your shop, anything that is running on a digital, a digital controller, any VFD, any phase converter that is solid state, has the potential for generating a bunch of this noise. Now, in the old days, when gorgeous three-phase power came into the shop, and each phase was a beautiful sine wave, and they were just, all out of phase from each other, and it would go into our three-phase system and power our stuff, you did not have this problem. When we had incandescent light bulbs that heated a piece of tungsten until it was white hot, and also thermally hot, you didn't have this problem. But now we have LED fixtures that have switching power supplies in each LED fixture, and it's generating noise. And when your lathe fires up, yes, you, Josh, I'm looking at you. When your lathe fires up with that, crufty motor controller in it, it may be generating a bunch of noise and pushing that noise back on the power bus. So these are all things which will tend to kill receivers. So your Wi-Fi access node sitting in the shop can't hear you anymore, when you turn the lathe on. When you go to make coffee, there you go, Art that makes art. He says, our microwave kills the Wi-Fi signal in our house. I'm going to help you with that right now, okay? You turn on the microwave, it generates 2.450, actually it's 2.451 gigahertz energy inside the microwave. And guess what channel your Wi-Fi is on? Channel 6. I don't even have to check. Your Wi-Fi is on channel 6. You're going to move it to channel 1 or channel 11. Okay? Check it out. Let's see. So these are all noisemakers. Now, you could go up to your lathe that's, and you can pop some ferrite beads in appropriate places and reduce the amount of high frequency radio noise that is coming out of that. You have to be careful and, talk to somebody if you don't know, but it's worth a try. These are not super expensive. I will try to get you some part numbers for these. I'll put them in the description of the video, and you can get them. Let's talk about Wi-Fi, okay? And so Wi-Fi is on two bands, and you've heard this probably, dual band Wi-Fi, 2.4 gigahertz and 5.8 gigahertz. Let's talk about 2.4 gigahertz. 2.4 gigahertz, also known as 2400 megahertz, just as an example, the center of your FM radio band as you're driving your pickup truck to the dump, and you're listening to your favorite radio station on 100.7, that's 100 megahertz. Okay. Wi-Fi is at 2400 megahertz. Amen, brother. Robin says, good reason to use proper cable designed for VFD output to the motors, which I would expect to be shielded. Okay. If you have this cable you're supposed to use and it's really expensive and it's got the wires to the motors and it's got a shield in it, there's a reason for that. Okay. So 2400 to 2483 megahertz, that's the 2.4 gigahertz Wi-Fi band, 2400 to 2483. So it is called an ISM band, International Scientific and Measurement Band, or manufacturing. I can't remember what the M is. And it's basically a license-free band to use for a whole category of things. One of the things that is in this band, besides Wi-Fi, besides some remote controls, besides model airplane controllers and FPV video backfeeds, all of this stuff is in 2.4 gigahertz. So is your microwave oven. So they're all in the same band. Anything you can do to reduce generating noise in that band, be it from your VFD, be it from your, noisy motor controller, or be it from your microwave oven, you should do. Now, your microwave oven, you can't change its frequency, but the Wi-Fi in your shop, you can. So if you go into the setup, industrial, scientific, and medical. Thanks. That's it, Evil. If you go into the setup for your wireless access point, you could give it the default channel to operate on. Practically, there's only 3 channels, 6, 11, 1, 6, and 11, okay? You'll read that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and in Europe, 12, okay? So my direction to you is pick the lowest one or the highest one, but not the middle one. And that gets you away from your microwave oven. So report back to me, Wes, and let me know if that does anything for you. Then we have this other band, this whole other band, 5.8 gigahertz, okay? 5.8 gigahertz is also an ISM band, but it's much bigger. It's capable of channels that are smaller. It actually can take several different channel sizes, which is kind of cool. But it doesn't have microwave ovens in it. And the propagation is poorer, which means your next door neighbor's noisemaker is unlikely to make 5.8 gigahertz noise at your location. My second recommendation is you should move everything to 5.8 gigahertz that you can. I know in our equipment here, the setup says prefer 5.8 gigahertz. In other words, when a device shows up on our network, the network's going to say, hey, we really want you to be on 5.8 gigahertz. And the device, if let's say it's your iPhone, it'll say, oh yeah, that's cool. I'll go at 5.8 gigahertz. And you'll end up on a channel in that band, and the results will be significantly better. I'm not going to talk about antennas on your wireless access point or any of that. I'm specifically talking about noise, okay? I think the contributors to RF noise in your shop right now are in order of worst to less worst or liverwurst is, believe it or not, LED lights, solar panels and their converters, and motor controllers or phase converters. The solar panel converters. Okay, no, Evils has a good point. He says high frequency start on the TIG. Yes. High frequency start on the TIG is designed to be exactly a noisemaker. Yeah, I know, Tuck. I know it's your entire garage, but we got you going, didn't we? So the solar panels, especially the ones with the built-in converters, sometimes you have solar panels that have a little microconverter in them. They're kind of spread out. They could be generating RF noise. A solar panel converter in the basement. I have one in my basement. I can detect the noise from it, but it's not horrible because it's well designed. Those generate noise. LED lights can go from, yeah, they generate noise, to, oh my gosh, they are killing us. That's the spectrum, by the way. That's the official FCC spectrum. So you might, if you're planning an LED upgrade, I would investigate the reports of any noise from these devices, but it's really something that should be looked at. Somebody has to get Tucker a microwave. It's the only noisemaker he doesn't have in the shop right now. Okay, so Robin asks that we elaborate on solid state VFD versus motor capacitor version. So this is actually, tell me if I'm heading down the path that you're imagining here, Robin. There was so-called static phase converters that still are sold, which is a capacitor trick, where it's sort of fooling the motor into having a third leg using capacitors, and I'm not even sure it has an inductor in it. Those are not inherently going to be noisy. The advantage of those is they're going to be quiet because they're not generating a leg. They're stealing power from the other legs to generate this third out of phase leg. However, they're horribly inefficient. And they're not too reliable. I hear lots of stories of guys blowing up capacitors in these things after not the lifespan they hoped for. So is that the motor capacitor version? Because they get the name static phase converter. Now, a solid state VFD, which is in the phase perfect converters that are in my shop, which are in the phase perfect converters in Josh's workshop, those electronically generate. They take all the energy. Now let me back up. Those converters synthesize the third leg. In other words, they make a third leg with a proper sine wave in the proper phase, and they feed it out in the three phases. They are running digital electronics. They are generating some pulsile shapes, but they're pretty good. Yeah, sorry, Robin. Are we not? We're not putting out audio? I am showing everything okay on my end, guys. This is what happens when you do it live, people. We're doing it live. Huh. Keep me posted. You guys on Discord, are you hearing me? Everything's looking green on my end. Discord seems problematic. Audio is fine on YouTube. Hang on, I'm going to hit a button over here, see what happens. No, it looks like we're doing okay on Discord for video. All right. Anyway, so the phase perfects are pretty good on noise generation, but I had a problem with a phase perfect converter where when I would run my vertical machining center up to 10,000 RPM and then command it to 0, for example, during the deceleration of the motor control, the spindle controller, it would generate enough electrical noise to kick out the phase perfect converter on a noise alarm. It had some sort of fancy noise alarm. So that happened a couple of times, and I spoke to the guys at Phase Perfect, and they said, go inside and flip this dip switch, and it'll turn off that noise detection. That's not an RF problem, okay? But that was a noise problem. So that was, again, noise being fed back onto the line by the motor controller in the machine. So the advantage of a real power converter versus a static converter is efficiency. You will get all the power. You know, if you're a 2 horsepower motor, you're going to get 2 horsepower. You're going to be able to deliver 2 horsepower, and not so with a static phase converter. So getting back to the noise, you will have machines that are more sensitive than others in kicking out because of the noise, and that has to do with online electrical noise. So back to RF noise, all of these things make noise. It's a real pain in the neck. Putting beads on wires where it makes sense can, especially if you find the noise source, can really improve your situation. Using the correct cables, especially if shielded cables are called for, can really improve the situation. Using metallic conduit in your wiring, especially in these 3-phase electronic converter powered systems like Josh has, using metallic conduit properly grounded will really help with noise also. Yeah, Evil, I remember the story. Evil says, I have a piezoelectric barbecue starter I can use to turn off one of my computer monitors. I'm looking forward to what my cheap TIG welder will do. Anyway, these are all ways to recognize these problems and maybe solve some of them. Correct use of ferrite beads, careful use of what we call bypass capacitors, and even winding wires through toroids, that's a little advanced, are things that could potentially help. But don't deafen your receivers. That is the problem. And get off the middle of the 2.4 gigahertz Wi-Fi band. All right. Greenwood says, will metallic flex conduit solve some of the noise problems? Yes. Yes, sir. As long as you could, it will help a lot, and it will help the most if on both ends of that conduit you get to that metallic covering, continue the metallic connection to the box, and also, you can never have enough grounds, and that should help you out. All right. So that's how we're going to keep your Wi-Fi going when your lathe is running. And the older the machine, the less treatment it likely had for noise suppression or radiated noise suppression. These days, things are pretty tough. I mean, the rules and regulations are there to make sure that we don't generate a lot of junk. Although that a lot of industrial and stuff will get the pass as long as the noise is in a certain band. That's why you might see some equipment that has a 13.56 megahertz signal. Like if you have an AC induction heater, if it runs at 13.56 megahertz or something like that, that magic frequency is specifically chosen worldwide, and everybody said, yeah, you can make all the noise you want on that frequency because you need something at that frequency. Everybody just use that frequency, and we won't use it for communications, and that's why that happens. Okay, any of you guys have questions, comments, or snide remarks? Because we're going to wrap it up, so that we can get into the after party roundtable and have some of those finger sandwiches. So if you're one of the guys that placed orders this week for PFG Stones, they're all packaged up. They go to the post office tomorrow. If you're looking for something flat or something to make something flat or something flat to make something flat, head over to pfgstones.com. If you want to join us on the Discord, head over to pfg.gg/Discord, and we'll take care of you. With that, I wish you a great Sunday. Get flat, stay flat. We'll see you in 2 weeks. Have fun.